viewers, welcome to this video on our channel where we are going to be talking about integration by part. To begin with, let us have a brief review or introduction to integration. Integration can also be known as our antiderivative because it is the opposite of differentiation. So for instance, if we integrate a function, we get its derivative. Now if we integrate, after differentiating we have the derivative. If we integrate the derivative, we'll come back to the original function. So it is a way of moving backward to the original function. And in this video we are going to concentrate on integration by part. We are going to take some examples. Let's say we take the example 1. Y is equal to y is equal to x cos x dx. Now integration by part, we use by part to integrate products. So now we are going to use different integration by part to integrate this. So if we want to integrate this function with respect to x, we are now going to have our equation to be in the form y equal to u dv. So in fact, anytime you are able to have or to identify u and dv in your equation, then you can use a integration by part to resolve the problem, to resolve the integration. So now you're going to let the function that you can easily differentiate to be your u. Yes, and so u in this case can be x, so that dv will be the other one, cos x. So now you differentiate du dx, here will be equal to 1, and so du will be equal to 1 dx. Now what about v? We have dv. To have v, we integrate v is equal to the integral of dv, which is the integral of cos x, and this is sine x. Exactly. Now whenever you have to integrate something in the form y equal to u dv, your integration of y or f of x dx, your integration here is going to be equal to it's going to be equal to uv minus the integral of v du. Exactly. So now it means that the integral of x cos x and all this dx will be equal to u. What's u here? U is x and v is sine x minus the integral of v du. Now v is sine x and du is 1 dx. So we're going to have our v is minus integral of v du, which is sine x times dx. Exactly. So this is it. Now it is equal to x sine x minus the integral of sine x dx, which is negative cos x, then plus c, the constant of integration. So this being true, it means this will be equal to lest we forget. Okay, that is okay. So now we are going to have equal to x sine x plus cos x, then plus the constant of integration as the integral of x cos x dx. So that is it. You can see that that is it for our first example on integration by part. So without wasting of time, let's go to example 2. We are going to integrate the integral of x e to the x dx. Like I said, you have to identify the function as u dv. So you can say u here is equal to x, so that dv is going to be e to the x. So if u is equal to x, you have that du dx will be equal to 1. And if dv equal to e to the x, then v will be integral of e to the x. And when you integrate e to the x, you equally have e to the x, then plus the constant of integration. So now if it's in that formula I gave you, it means the integral of x e to the x will be equal to dx will be equal to is equal to uv. U is x and v is e to the x minus the integral of v du. So v is e to the x and du is 1 dx, so e to the x dx. Alright, so this will give us x e to the x minus, when we integrate e to the x dx, we have e to the x minus e to the x. So now we have this as e to the x into x minus 1, the integral of x e to the x dx. So this is what we've got. Now sometimes you may have to apply the rule of integration by part more than once, and so we're going to see such in example 3. So let's go to example 3 now. In example 3, let's find the integral of x squared cos x dx. So in this case, we are still going to have our u and our dv. Let u to be x squared and dv to be cos of x. So if u is x squared, then du dx is equal to 2x, and so du is equal to 2x dx. Then if dv is equal to cos x dx, then v will be the integral of cos x dx, and so v will be equal to sine x. So now we can now fit it in the formula as we have been doing. We have that the integral of x squared cos x dx will be equal to uv. Our u here is x squared and our v is sine x minus the integral of v du sine 2x sine x dx. Where am I taking 2x from? We have integral of v du. This is our v sine x, this is our du 2x then dx. That is it. So now this is equal to, we now see that at this level we have to apply again integration by part here to resolve this. So that is why I said sometime in the question you may use integration by part more than once. And so we are going to use integration by part to resolve this one here as well. And then this is going to be equal to x squared sine x minus 2 times the integral of x sine x dx. And so we now use integration by part there. Now the integral of x sine x dx with the use of integration by part is going to give us sine x minus x cos x by doing what we have been doing. So now we have x squared sine x minus 2 times, now when we integrate this, we have sine x minus x cos x, and so this is the integral. And so the integral of x squared cos x dx will now be equal to x squared minus 2 x squared minus 2 times sine x then plus 2x cos x, then now plus the constant of integration. So this is it for the integration of x squared cos x dx. Alright, dear viewers, here we come to the end of this tutorial video. If you have any more questions on integration by parts, you can always get in touch with me through the number on your screen, and so I will be of help. See you in the next video.